back to part 2, and we are now going to talk about solving rational equations instead of just analyzing them and looking at their asymptotes and the zeros and where they're increasing and decreasing. We're now going to actually get solutions. There are 2 methods to do this. The first method is if you're allowed to use a graphing calculator, you can actually graph both sides of the equation, and then you would determine, can you figure out what part of the graph? You would figure out where they intersect. And you can do that with the calculating of that command where you find the intersection. The second method is algebraically, because sometimes you're not going to be allowed to use the graphing calculator, and you're going to have to figure out by getting common denominators or cross-multiplying or combining like terms and factoring so that you can solve for the zeros yourself. So I'd like to work a couple examples. The first example here is 20 divided by x plus 3 minus 4 equals 0. Now that's important. It says equals 0, so you have an equation here and you can now solve this. I'm going to move the 4 to the other side. If I do that, then I can have 2 equations that are equal, and I can then cross multiply. So if I have 20 over x plus 3 equals 4 over 1, now I can cross multiply and have 20 equals 4, I'm going to distribute 4x plus 12. Well, this is a very simple Algebra 1 equation, right? I want to move the 12 to the other side, so I would have 20 minus 12, which would give me 8, equals 4x. So x must be 2. And if I plug that back in, if I substitute 2 back into the equation, it still makes this valid. It doesn't make it equal to 0, so it is equal to 2 plus 3 gives me 5. 20 divided by 5 is 4 minus 4 is 0. So 2 is in fact the solution. Let's look at example 3. Example 3 has 3 fractions, and now I know that when I add fractions, I need a common denominator. So if I factor this side right here, this denominator, I need factors of 18, and when I add and subtract them, I get 3. Well, that's going to be 6 and 3, right? I need a negative 3 in the middle, so I need a negative 6 and a positive 3. That gives me my negative 18. Well, look at this. This is very convenient. It's the same factors. So what I'm going to do, this is a shortcut. Now, you've probably done this before. But I'm going to take the whole darn thing and I'm going to multiply it by this common denominator. And x minus 6. Now when I do that, I'm going to distribute, just like I would any other parenthesis, I'm going to distribute this times each of the fractions. When I do, the denominator will cancel with part of it. But the nice thing about doing it this way, by multiplying the whole problem by the common denominator, is I eliminate the fractions, which is really, really nice. So let's do that. So here, when I distribute, my x plus 3's cancel, and I'm left with 2x times the x minus 6. Plus, let's do this fraction. Now the x minus 6's will reduce, and I'm left with 3 times x plus 3. Last fraction, they have the exact same terms, so I just have 27. They will reduce and cancel. Now let's clean that up. Distribute, I'm going to have 2x squared minus 12x plus 3x plus 9, and I'm going to bring that 27 over. So I now have 2x squared. Negative 12 plus 3 is going to give me a negative 9. Positive 9 minus 27 gives me a negative 18. It would be really, really nice if that factored. Let's see if that factors. 2x, x. Okay, I need factors of 18. So I'm dealing with 1 and 18, 2 and 9, 3 and 6. I need to get a 9. And I'm going to try, I can try any of them. I can try different ones. If I stick a 3 here and the 6, this gives me 12. That gives me 3. 12 minus 3 will give me my 9. I need my 12 to be negative, my 3 to be positive. And then a positive 3 and a negative 6 gives me a negative 18. All right, let's look at each of those. That one will give me, if I do 2x plus 3 equals 0, x equals negative 3/2. This factor, x minus 6 is 0, x equals 6. Now we need to go back and check to see if both of those work, if they're both feasible. All right, if I take the 6, and if I plug that back in, because I can tell right away by looking at it, if I plug 6 in here for x, that will give me 6 minus 6 and give me 0 in the denominator. That won't work. So I know that that answer is not valid, extraneous, right? So the only answer is negative 3/2. And you can actually plug that back in, and you can see that that does work. The negative 3/2, negative 1.5, is a valid solution for that equation. All right, I will see you in class when we will work some of these together. Thank you.